Hello everyone, you're welcome to today's class. So in this class we continue our class which is we're still on the same topic, probability, as you can see on the board. But today we're looking at two concepts inside probability, and we want to look at experimental probability, and at the same time we also look at part of playing cards. So when we talk about experimental probability, let's start with experimental probability. But before we start, I would like you to make sure that you watch the video till the end, because there are some things that I'm going to reveal in this video. If you skip it, you will not get the maximum benefit from this video. That's the reason why you need to watch from beginning to the end of this video. So let's get started. Now look at experimental probability. The probability we have been looking at before are theoretical probability. Because we have two types of probability here. We have theoretical probability and we have theoretical probability. Theoretical, and then we have experimental. When we talk about theoretical probability, for instance, we have coin. So when you toss a coin, is that you get a head or you get a tail? That one is theory. You can have it to be what? 1, that is 1/2. Probability of getting a head is 1/2, while probability of getting a tail is also 1 divided by what? 2. That is theoretical probability. But in this case, we want to see by experiment. If you carry out experiment, there are some times we need to carry out experiments or we carry out a survey before we can get the probability of some events. Or we want to determine what will be the outcome of a particular event if something happened. So that is the essence of this experimental probability. Hope I'm making sense. So in that case, let's say for instance we have example of experimental probability. We can carry out experiments on coin, we can carry out experiments on a dice, and so many other things. So that's the same process. Now when we talk about experimental probability, it's also known as relative frequency. Relative frequency. Frequency. It's also known as relative frequency. Let's assume we have this table. Let's have a table this way. Have this table. So we want to carry out experiments on a coin. We want to carry out experiment on a coin. We want to carry out experiment on a coin. We want to toss the coins so many times. So we want to see what will be the outcome. So, and for that coin, we want to check what will be the outcome on head. On what? On head. Head, particularly, we want to look at head. So here we're going to have number of trials. Number of trials. Then we have here, we're going to have successful number of successful outcome. Number of successful outcome on what? On head. Right? Then we're going to have for another one here, relative frequency. Relative frequency. So in this case, so we're going to assume now, we're going to assume that when we throw the first 10 trials, or let's say the first 15 trials, the outcome out of the 15, we have like 11 x. We have 11 x. X appears 11 times. What will be the relative frequency? Relative frequency here will be the number of successful outcome of x, right, divided by the number of trials, total number of trials. How many times have we tossed the coins? We tossed it how many times? 15 times. And out of the 15 times, 11, we got 11x, right? So in that case, relative frequency will be 11 divided by what? 15. That is experiments. So we carry out another experiment, maybe 50 times. Out of the 50 times, egg appears 29 times. So relative frequency here will be what? 29 divided by what? Divided by 50, and so on and so forth. Now, you'll be asking, what's the purpose of this? The purpose of this is that if, as we want to have a trial of about 500 trials, we want to toss the coins 500 times. So we can predict the outcome of X, the number of outcomes of X. So what will be the expected number of eggs when the coin is being tossed 500 times. That's what we want to look at. So in that case, so we're going to have this. Since I said that experimental probability same thing as what? Relative what? Frequency. So in that case, we're going to say relative frequency from this table now is the number of successful outcome of the events, number of successful outcome of the events divided by what? Total number of trials. Total number of what? Trials. Having said that, so we will now look at expectation of an event. So expectation of an event is showing how often we expect an event to happen. This is want to use this to predict what will happen to an event in the nearest future. So what do we expect it to be? So that's what we want to look at here. So and this is usually calculated by what? It is calculated. It is what? Calculated as follows. So which is relative frequency of that event. Relative frequency of that event. Relative frequency multiplied by number of trials. Number of what? Trials. So assuming we are going to ask us what would be the expected number of x, number of eggs when the coin is tossed 500 times. 500 times. So when the coin is tossed 500 times, and from our experiment, from this experiment, we experimented that 15 out of 15, 11 eggs, we have 11 eggs. So we can make use of this relative frequency. Let's ignore this second part here. So we can make use of this to be relative frequency of eggs, relative, so the solution will be relative frequency of eggs will be what? 11 from the formula number of successful outcome of the event. The event is what? X, which is 11, over the total number of trials, which is 15. Am I with you? Now, expected number of eggs at these 500 times will be what? 11 over 15 multiplied by what? 500. I hope I'm making sense. Alright, this is first example. A fair dice is thrown 200 times. Right? So find the number of times you would expect to get a 5. Then the first one be a number less than what? 5. So the first thing you ask yourself here, we're not given the relative frequency. So the first thing you need to do is to get your relative frequency. How are you going to do that? So if the dice is thrown once, let's have the first one. Solution A. So we need to look at one trial. So when you try it once, when you throw it once, what will be the outcome of what will be the relative frequency of getting 5? So relative frequency of 5. Relative frequency of getting 5 is what? Because 5 can only appear once on a dice because it has 1 5. Then how many faces do we have there? We have 6 faces. So in that case, that would be what? 1 divided by what? 6. That's the relative frequency of getting what? 5. Now, but the question is, find the number of times you would expect to get what? To get 5. So how many times are we going to get 5? That's what we want to get. So in that is expected number of 5. Expected number of 5 now will then be equals to the relative frequency that we're going to have done now, the relative frequency multiplied by the number of trials. So number of what? Trials. Number of trials. Hope that is clear, because we said number of trials, expected number of outcomes is what? Relative frequency multiplied by what? Number of what? Trials. Is that clear? So that means we're going to have relative frequency 1/6 multiplied by how many trials? 200 trials. Are you with me? So that means we have this 2 year 3, 2 year, that is what? 100. Then that means we have 100 divided by 3, which will give us 33.3. That is 33 what? Times. So we are expecting to get what? 33 times. That means that 5 will appear 33 times out of what? 200 times that we have here. I believe that is very clear to you. So if that is the case, then B part. The B part is a number less than 5. A number less, what are the numbers that are less than 5? 4, 3, 2, 1. So in that, so number less than 5, they are just 4. Right? So relative frequency of number less than 5. So number less than 5 be, let it be what? F. So relative frequency of F will then be what? 4 divided by 6, which is what? 2 over what? 3. Right? So expected of a number less than 5. So expected number less than 5. Less than 5 will then be what? The relative frequency, which is 2 divided by 3 multiplied by what? Multiplied by 200. Sorry, 200. Right. So this is it. So this is 6, then 6. So that is 2 times 66.6 0.7. That's 6.7. 2 times 7, that's 14, carry 1. 2 times 6, that is 12. Plus 1, that is 13, carry 1. 2 times 6 again, that is 12. Plus 1, that is what? 13. So that is 133, which will be what? 133 times. So we are expecting to get 133 times of what? All numbers. Any of the numbers that are what? Less than 5. I hope this is very clear. So that is that on this. So we look at another example to round this part up before we move to the next objective. This is the second example. In an experiment, a dice is thrown 200 times. Sorry, 500 times. 500 times. The table below shows the outcomes. So this is the outcome. That is, the experiment has been carried out, and these are the outcomes. So it means that 1 appears 81 times, while 2 appears 83 times, 83 times, while 3 appears 90 times, and so on and so forth like that. Since you have been given this, and you have given the number of times the experiment was carried out, so you can get the rest of the answer. So find the relative frequency of getting a 3. So a 3 here, so relative frequency, as I've told you, relative frequency of, that is A, relative frequency of getting a 3. A 3 will then be, what is it? So 3, what is the frequency of 3? The frequency of 3 is 9. That is, number of successful outcome of 3 is what? 90. Divided by total number of trials. What is the total number of trials? So we have thrown the dice 500 times. That is, the number of trials was 500 divided by what? 500. So that is how we cancel. We have 9 divided by what? 50. That's the relative frequency, which is also the probability or experimental probability. So they ask what is the experimental probability of getting a 3. They are still asking you relative frequency. You know, I said that relative frequency is the same thing as what? Experimental probability. That is that on that one. So that is A Roman figure 1. So Roman figure 2, a multiple of 2. A multiple of 2. From what we have here, what are the multiples of 2 that we have? Multiples of 2. Multiples of 2. We have 2, 4, and what? 6. We have 2, 4, and 6. So we're going to have 2, 4, and 6. What will be the experimental probability of a multiple of 2? Multiple of 2. So we have 2, we have 4, we have what? 6. So that means we are going to add multiples of 2. The outcomes of this will be 83 plus 84 plus 87. So our outcome here will give us answer. So that's we have 83, 84, 87, 14, 1, 16, 24, 25. That's 254. 254. So relative frequency of multiple of 2. Relative frequency of multiple of 2 will then be equal to 254. It is thrown how many times? That is number of successful outcome of the event, which is 254 divided by what? 500. So we can reduce it to its lowest 10. We can reduce to its lowest 10. So we have, that would be 2 here 1, 2 here 2, that's 7. 127 all over what? 250. So that is that. Then for B, the B part here. The B part here, how many times would you expect to get a 2 if the dice is thrown 1,500 times? Now, it is thrown 500 times, we got 83, 2 appears 83 times. So how many times will 2 appear when the die is thrown 1,500 times? That is expectation that we just told you. So expected number of an event here to be what? Relative frequency of that event, right? Of events multiplied by what? Number of what? Trials. So in this case, for 2, relative frequency of 2 will be what? 83 divided by what? 500. Multiplied by how many number of trials? 1,500. Multiplied by what? 1,500. Then we cancel 0, cancel 0. 5 here 1, 5 here what? 3. That is 83 multiplied by what? 3. So that gives 9, 249. So that means that 2 will appear 249 times if the dice is thrown 1,500 times. You can see that we are predicting that. So when we should throw it 1,500 times, this is the expected outcome. This is what we are expecting to get. We are expecting to get what? 2,249, which could be correct and which could also be what? Wrong. We might not get it, but we can also what? Get it. Is that clear now? So that is everything about experimental probability, and we have some other questions that we can solve, then I'll post it on the video. So in that, on the channel rather. So we move to the second objective, which has to do with playing cards. So let's look at that. So you will come back. So we're going to be looking at playing cards now. So we want to see how questions are being solved on playing cards and some other stuff that we have under it. So in this one, we have, in a standard playing cards must have 52 cards. Standard playing card must have 52 cards, and that 52 cards contains 4 suits. So a pack of cards are in 4 suits. So the suits are diamonds, hearts, spades, and clubs. So in each of them, we have 13, 13, 13. The signs of numbers on the card are A, you see, we have A to K. We have number 2 to 10, then A, J, Q, K. A is ace, and Q is queen, and there are 4. Then K is king, and J is jack. So we'll look at it. Let me show you this diagram and see. Look at this diagram, just a summary of it. So in it, we have diamond, we have heart. These are the suits: diamond, heart, spade, and a club. Now in diamond, you see 2 that appear once, you see 3 appears once, and so forth to what? To J, to jack. Now heart the same thing, spade the same thing, club the same thing. What this implies, you see that you can see diamond and heart in red color. So the cards that are red in color are diamond and heart, and they are what? 13, 13. That's another aspect we're going to look at. Then we have spade, we have club. Club and spade are black. I'll show you that in a moment. So they are 13, 13. So if you add 13 plus 13 plus 13, it gives you what? 52. Then if you add all these 4 together, it will also give you what? This 52. I hope this is getting clear. So in that case, question can come in any form. How? I can ask you, what's the probability of picking 10 of diamonds? 10 of diamonds. How many 10 of diamonds do we have? We only have 1. 10 of diamonds is 1. Ace of spades. Ace of spades is also what? 1. But if I only mention this, what's probability of picking a queen? What's probability of picking a queen? How many queens do we have in the card? We have 4 queens. 4 cards that are queen. Then that means that 4 divided by what? 52. I believe it's getting clearer. But if the person is, what's probability of picking a spade? A spade will be what? 13 out of what? 52. I believe this is very clear. They can also ask you, what probability of picking red cards? Probability of picking red cards. How many red cards do we have there? So we have 13 and 13. Because diamond and hearts are what? 13. So in that case, red cards will be what? 26. Probability of red cards will be 26 out of what? 52. I believe it is clear. So let me show you this. So if you look at the cards here, so this is spade. You can see it's in black. You can see this is spade. We also have this is diamond. You can see red diamond. They also have this. This is club. This is club, and then there's another one. This is our hearts. It's also what? Red. That's what we have. Hearts and diamonds will be red. So let's look at questions on this. How do we solve problem on this? So let's look at this question. So we have this. A card is selected from a well-shuffled standard pack of 52. Sometimes the question mention 52 cards. So anytime you see well-shuffled standard card, pack of cards must be 52. No, they must be 52. So what's probability of getting a diamond, probability of getting a queen, an ace, a red, the ace of spades, any card other than an ace? So these are the things you want to look at right now. Having gone through the explanation of our cards now, so let's look at this example we have shown it on the slide there. A card is selected at random from a well-shuffled standard pack of 52 cards. What is the probability of getting a diamond? And I've shown you earlier on that diamonds in the solution here. So for the first thing you need to do, number of diamonds, okay, or let's diamonds be G, right? So number of diamonds now is how many? 13. We have 13 diamonds there. So probability of getting a diamond now, we still know A. Probability of a diamond, D, will then be 13 out of what? 52. So which is what? 1 divided by what? 4. You reduce to its lowest step. Right? Then B, a queen. So we have let queen be Q. So number of Q will be what? How many queen do we have there? So there's one queen for diamond, there's one queen for spade, there's one queen for hearts, there's one queen for what? For club. So which means we have 4 queen cards. So 4. So therefore, probability of Q, which is queen, will be probability of Q, which is queen, will be what? 4 divided by what? 52. Because total number of cards is what? 52, and that gives us 1 divided by what? 13. Then the second one, the third one, which is an ace. An ace, you see ace, queen, king, and jack. They are 4 each. Then the number from 2 to 10 are also 4, as I've displayed earlier on. So we have 2, 3, 4 to 10. They are also 4. So the same thing will happen to an ace. So let ace be A. So therefore, number of A is what? 4. That is probability of A is what? 4 divided by what? 52. That is what? 1 over what? 13 as well. Then the next one is what? A red. Probability of what? A red. Probability of a red now. Let's solve it here. Probability of a red. So how many red cards? The first thing you have to do is what? How many red cards do we have there? So let red cards be R. Right? Therefore, number of R is what? So we have I told you that the diamonds are in red colors and they have 13 diamonds. And another one we have hearts, also red. So 13 hearts. Then that means 13 plus 13, that gives us 26. So therefore, probability of red cards will be what? 26 divided by what? 52. That is 1 over what? 1 over 2. Hope I'm making sense. Alright. So the second to the last one is the ace of spades. Ace of spades. Ace of spades, we have ace, then we have spades. We only have one. Ace of spades. So go back to the slide. Ace of spades is 1. So ace of spades, let ace of spades be AS. Therefore, AS, number of AS is what? 1. So therefore, probability of AS, ace for spades, will be what? 1 out of what? 52. And the last one here can be solved in 2 ways. How? What do I mean with that? Any card other than an ace. Any card other than an ace is talking about all other cards except what? Ace. How many aces do we have there? We have 4 aces. So we subtract 4 from 52, we're going to have what? 48. So other cards other than ace. Other cards except ace. Let it be not ace. So therefore, number of not ace will be what? 52 minus 4, which is what? 48. So in that case, we're going to have probability of not ace will be what? 48 divided by what? 52. And that gives us what? 12 over what? 30 by the time we solve it. So that is that. And we can solve it another way. How? We have calculated the probability of ace to be what? 1 over 13. So not ace is talking about, so not ace now will be this. Not ace. So probability of not ace is 1 minus probability of what? Ace. So probability of an event will happen is probability of is 1 minus probability of event that the event will not happen. Again, probability of event not happening is 1 minus probability of the event happening. So that is, probability of this event of not 8 is 1 minus probability of what? 8. So that means we have 1 minus what? What probability of 8 is 1 over 3. That's minus 1 over 13 rather. 1 over 13. So by the time you subtract, you have 12 over what? 13. Don't forget, when you are subtracting a fraction from 1, you don't subtract the numerator from the denominator. You subtract what? Numerator from the denominator. That will make your answer's numerator to give your what? Denominator your answer, which is 12. So that is 13 minus 1 will give us 12 divided by 14, divided by 13. So let's look at it here. How to prove it? That means this one is 1 over 1 minus 1 over 13. Then find the LCM, which is what? 13, right? Which is 13. So that is 1 in 13 is 13. 13 times 1 is what? 13. Minus 13 is 13, 1. 1 times 1, 1. So 13 minus 1 is 12 over what? 13. So instead of you going through this, you can, once you see it like this, just know that 13 minus 1 will be 12 over 13. Nobody will penalize it for that. That is how to short to that. I think I've solved all the questions. That is it. That's the end of it. That is CAS on CAS. So we still have enough time to solve questions on this. When you answer your questions on the platform, then we see solution to it, and we'll also solve the question for you. So this is what we're going to solve today in this video. So I don't want the video to be too much. So if you are new to this channel, kindly subscribe. And don't only subscribe, make sure you turn on notification bell. So anytime I release video like this, you'll be able to have access to it and benefit from it on time. And don't forget, if you find this video useful and helpful, give us a thumb up and make sure you subscribe and share the video with your family and friends. So we'll meet in our next class. Bye for now.